Alright guys, welcome back to your 58th C++ tutorial, and in this tutorial I'm going to be talking to you guys about something called a function template. Now before I actually, just give you guys a definition and show you guys an example, let me go ahead and throw a quick scenario at you guys. So say you're working for Microsoft and your boss Bill Gates comes up to you and he's like, Bucky, I need you to create the world's perfect calculator. So you say, alright Bill, let me be, I will do this. So the first thing you would probably do is this. You're going to create a function maybe to add two numbers together, add two integers together. So you're going to write int as your return type, name the function add crap because it's the most professional thing I could think of. And then you'd write like int a and int b for your two numbers. And then all you need to do in the body is, add them together and return them. So like return a plus b. So there's your function right there, add crap. It adds two numbers together. So whenever you want to use it in your main, you would need, two integer variables like int x equals 7, y equals 43, and we'll store the answer in a variable called z. So now we would put z equal to, what I name it, add crap, and we would just throw our two variables in here. By the way, I got a new keyboard the other day and it's really different, so I keep like hitting, the wrong keys that are only one off, so just deal with me if I have a lot of typos in this tutorial. So anyways, what we do is go ahead and throw our two variables in there and then just print it out on the screen, make sure I didn't mess anything up. So C out Z end line. So let's go ahead and build and run this and make sure we didn't get any errors, and we get 50, and upon checking we find out that 43 plus 7 is indeed 50. So that is our function add two integers together. But he didn't say I want a program to add two integers together, he wants a calculator. So we're saying alright. So we have a bunch of different, types of numbers besides integers. We have a float, a long, double, every, some with decimal points, some just with basic integers. So we're going to need to take this function and, copy it and, basically make the same exact function, but make this one using doubles, make this one using floats, make this one using long, and as you can see already, this program is going to get huge and it's going to get messy, and if we ever decided that we messed up something, like we put minus here instead of plus, we're going to need to go back on every single function and fix them all, and it's just going to be a big pain in the butt. So you're saying, alright, since this function pretty much is doing the exact same thing, wouldn't it be nifty if we could just, instead of this int right here, just replace it with like a generic data type and throw in any information we want? Well, that would be a little bit too easy. Or would it? Is there a way that we can indeed build functions that could handle multiple types of data? Well, you guys are in luck because that's exactly what I'm going to be teaching you in this tutorial. Instead of building a function that can only handle one type of data, if we're building a bunch of different functions that did the exact same thing, why not code this to handle multiple types of data? Well, in order to do that, we first need to build something called a template definition. And what a template definition is going to do is we're going to be building a generic type of data. Basically all we're going to be doing in this line of code. So let's go ahead, and in order to do that, you first write the name template. And now, inside angle brackets right after it, you write class. And then you give your class a name like Bucky. Now Bucky is pretty much a template. It's not, an integer, it's not a float, it's not a character, it's just a generic type of data. So then we can use that generic type of data. Let's go ahead and copy Bucky, and instead of, having int or double or long, we can just go ahead and type in our generic type of data anywhere we would use, a specific type of data. So now your return value is Bucky. Instead of passing it in an integer called a, you're passing it in a Bucky called a, and instead of passing it in an integer or a float or a double called b, we're just passing it in a Bucky called b, whatever the heck a Bucky is. So now let me go ahead and run this, and I'll show you guys that this works beautifully, just like that. So what's happening is this. Instead of building functions that take, that take two integers and return an integer, we can just throw in generic data types instead using this template definition right here. So your template definition is pretty much building a generic type of data, and then instead of, taking a function that, works with one type of data, you can just use that generic type of data to work with any different type of data. So, we used integer right here, but say we wanted to use double. And remember, a double is just something with a decimal point, like 7.65 or 43.54. And now, whenever we go ahead and, yeah, I just accidentally pressed something. Let's go ahead and, yeah, now my computer's freezing. That is, yep, and that's just great. Not responding, and X that out. Yeah, just go ahead. I'm not in the middle of a tutorial or anything. I can wait for you guys. You know what? Minimize you. You can stay there if you want. Let's go ahead and build and run this. OMG, are you flipping kidding me? Must be stopped to do a rebuild. Yes, I want to stop it. See, that's what you guys get when you buy a new keyboard and all the keys are like all over the place. I swear, this is like a keyboard. Oh, wait a minute. Oh, it was upside down. Okay, it's fine now. Okay, so as you can see, instead of integer, if we throw a double in here, it calls the exact same function and it works fine. So basically, whenever we make function templates, we're doing this. We're making first a generic type of data, and instead of making a function specific to one type of data, we're going to use that generic type of data. And now whenever we call that function, C++ is going to automatically see that X is a double and Y is a double, so you must be working with doubles here. So instead of Bucky, it's going to substitute the word double. That's literally what it does. It puts double right there, and double right there, and double right there. And it runs it just like that. And now if we go ahead and we had an integer like 7 and 43, it will take anywhere where it said Bucky and it will change it into int, int. So as long as we have that generic type of data like that, it's going to go ahead and it's going to work with any data we have. The one thing that you can't do is you can't have an integer x and a double y. You can't have two different types of data. Well, actually, talking about that, there is a way that you can make template functions that take different types of data. But for now, I just want to cover whenever you have a function that does the exact same thing and you want it to be able to work with multiple types of data, you can build a template function. And what that means is you're pretty much building a generic type of data, and you're going to be using that generic type of data inside your function instead of, integers or doubles or anything like that. So then whenever you use your function later on, you can use it with integers, doubles, or you can even build it to work with like strings and characters if you want, but you can't really do that using addition. So anyways, in this tutorial we learned how to work with one type of data using a function template. In the next tutorial, I'm going to show you guys how to work with multiple types of data, like how to add an integer and a long together, or a double and a float, and all that good stuff. So thank you guys for watching, and I'm going to go take a keyboarding class with this keyboard, and hopefully when you come back, I'll be a little bit better. So one last time, thank you guys for watching, and don't forget to subscribe, and I'll see you in the next video.